Okay, we're now on to the textbook questions on surds, so exercise 2B, and we're going from question 5 to question 10, so the green, slightly easier questions, but we'll go through all of them in a bit of detail, so let's go through them. Question number 5, let's begin. So it says simplify this. And when it says simplify this, really it is saying that you want to kind of get rid of the surds on the bottom, or manipulate the surds off the bottom onto the top. And what I'm seeing here is I've got 1 over 1 plus root 10 and 1 over 1 minus root 10. They're very, very similar fractions. You actually want to go and cross multiply here. Okay, so we're going to begin. I'm going to write it out in full again. So we've got 1 over 1 plus root n plus 1 over 1 take away root n, and you want to multiply the first fraction by 1 take away root n over 1 take away root n. I'll go and do that in blue, because I'm going to times the first fraction by 1 minus root n over 1 minus root n, and again you can do that because effectively this is timesing through by 1, because 1 minus root n over 1 plus minus root n is just 1. And you'll see why I'm going to do this, because if I do this, if I do something similar with this fraction, okay, 1 over 1 minus root n, and I times it by this time, so I go and times this one by 1 plus root n over 1 plus root n, the fractions are going to be under the same denominator, which is really useful. And then we're going to get the difference of two squares, and things are going to begin to cancel, which is good. So if I go and consider this sort of first part over here and go and simplify it, well, I've got 1 take away root n times 1 just 1 take away root n. And then the bottom part, I'm going to leave it actually, right? Because I'm going to go and add on. We've then got, looking at the top part, 1 times by 1 plus root n, which is going to keep it as 1 plus root n. And then because, right, you can see now, and this is the whole point of cross multiplying, you can see the denominators, we've got 1 minus root n times by 1 plus root n, and the same thing over here, we've got 1 take away root n times 1 plus root n. It's all going to be underneath the same denominator, which is useful. So we can go and combine this now and say we've got 1 minus root n bracket 1 plus root n. Okay, you could have written, right, this first part, 1 minus root n over this plus this over this, but you can just combine it to be underneath the same thing. It means the same thing. Now, what you've got to go and spot really is that this below, you could expand the brackets, but again, this is the difference of two squares. This is currently written, so the denominator here, this is written in the form, a take away b, a plus b. Okay, and we know, right, if you expand brackets in this form, it's going to go to a squared take away b squared, where in this case, a is equal to the first number, a is equal to 1, so we can go and say a is 1 and b is your second number, which is just root n. Right, so a squared is going to be 1 squared, which is just 1, take away b squared, which is the root of n squared. Well, 1 squared is just 1, root n squared, the square and the root cancel, which is going to be take away n. So this fraction is going to go to the bottom. Okay, this part we've just seen is the same thing as 1 take away n. So we get 1 take away n, and you can see there's not a single surd in sight on the denominator of that fraction. And then on the top, well, we've got 1 plus 1, which is going to be just 2. Okay, so you've got 2. And then I can see we've got a negative root n, add a plus root n, they cancel to make 0. So your answer is just going to be 2 over 1 take away n. So this question is looking at cross multiplying, okay, because then you get the difference of two squares on the bottom with these brackets, and then you can just go and manipulate it from there. Okay, nice question to begin. Question number 6 says, show that this 4 over root 20 take away root 12 can be written in the form root a plus root b, where a and b are whole numbers. Okay, so this is rationalizing the denominator. You want to manipulate the surds from the bottom and get them on the top. So we've got 4. Let's write it in red. Keep it consistent. We've got 4. Now what I'm thinking is, right, root 20 and root 12, you could just go and times through top and bottom, as we've been doing, by root 20 plus root 12 over root 20 plus root 12. But I'm noticing root 20 you can simplify and root 12 you can simplify, which might be useful. I'm not sure. It might be a waste of time. I'm guessing, right, root 20, right, we know we can write this as the square root of 4 times by 5, which is the same thing as 2 root 5. Okay, and root 12 is the same thing as root 4 times by 3, which is equal to 2 root 3. I've just simplified down those surds. We've got different numbers in the surds. Not looking too useful, but okay, right, it will be useful, as you're going to see in a second. So root 20, we've just said, is the same thing as 2 root 5. And we're taking away root 12, which is the same thing as 2 root 3. And it is useful. We're going to save a bit of time here because 4, 2, and 2 can all be divided by the number 2. So I can divide the whole fraction by 2 to give me 2 over root 5 take away root 3. And now it's just going to save a bit of time. Now when I go multiply, okay, by rationalizing the denominator, we now know we times it by the bottom with the change sign. So root 5 plus root 3 over, don't know why I did that with that line there, but okay, root 5 plus root 3. Okay, now timesing this together, timesing the top parts, okay, timesing brackets, single bracket, so 2 times by 2 times root 5, we just write simply as 2 root 5. We've then got 2 times by root 3, which is plus 2 root 3. And of course, again, this part here, you could expand the double brackets, but we know that this stuff, again, is in the form a take away b, a plus b. That is your difference of two squares form. So it's going to go and expand it into this form, okay, where in this case a is equal to root 5 and b is equal to root 3. Well, a squared is going to be root 5 squared, which is just going to be 5, so it's going to be 5. Take away b squared is going to be root 3 squared, which just gives you 3. So 5 take away 3, which is 2. So then this can all be divided by, over here, all being divided by the number 2. And this is working out really nicely because then what happens here is these 2's are just all going to cancel if you divide through by 2. So you're left with, as your answer, just being root 5 plus root 3. And that is your answer, okay? You've written it in the form, always check it right, this is in the form root a plus root b. A is equal to 5 and b is equal to 3, where a and b are whole numbers. Perfect. Okay, let's go and state that. So a is equal to 5 and b is equal to 3. Perfect. Okay, so there is our answer, right, with a being equal to 5, b being equal to 3. Excellent. Another rationalizing the denominator one, it says show that this can be written in the form a plus b root 2, where a and b are constants, numbers to be found. Okay, let's write the question out and let's have a think about it as we write it out. We've got 5 plus root 2 all over 3 take away 2 root 2. Now this one, I think it's just a case of simply timesing through by 3 plus 2 root 2 over 3 plus 2 root 2, because you can't simplify root 2's any further. We can't kind of make it easier for ourselves. So it's just a process of really going through this in longhand. Okay, so let's go put these into brackets as well to make it a little bit clearer what is going on here. Okay, so if we go and consider the numerators timesing together, so we're going to look at this times by this to begin with. So let's go and look at the numerator parts. Okay, to begin with, numerator. So we've got 5 times by 3, which is 15. We've then got 5 times by 2 root 2, which is going to be plus 10 root 2. We've then got root 2 times by 3, which is going to be plus 3 root 2. We've then got root 2 times by 2 root 2, which is going to be plus 2 root 4. And then we just got to tidy it up a little bit. So we've got the 15. These parts here, 10 root 2 plus 3 root 2. These are like terms because we've got a root 2 underneath both of the surds, which is lovely. So we've got 10 root 2 at 3 root 2. It's going to be 13 root 2. So plus 13 root 2. Don't know why I changed colour. That's okay though. And I've got this root 4 is equal to 2. 2 times 2 is 4. So it's going to be plus 4 on the end. And then just simplifying it again, because now I've got a 15 plus a 4 like terms. It's going to be 19 plus 13 root 2. That is the numerator part considered. Good. Excellent. Let's now go and consider the denominator part. Okay, denominator. So we're doing 3 take away 2 root 2, bracket times 3 plus 2 root 2. And again, this is of course in our form now, difference of 2 square form, a plus b. A take away b, right, which we know, right, is going to go into the equivalent, but it's going to go into a squared take away b squared form, where in this case a is equal to 3 and b is equal to 2 root 2. So a squared is going to be 3 squared, which is equal to 9. Take away b squared, well 2 root 2 squared is 4. root 2 squared, root 2 times by root 2 is going to be root 4, which is 2. So it gives you 2 in there. So that's going to give you 9. Take away 4 times 2 is 8. 9 take away is equal to 1, which is nice. So it's just going to make it nice and simple. I'm going to go back over to here. So I can write it. The top parts gave me 19 plus 13 root 2 over 1. If you write it over 1, you don't need to write it as that. So I believe that is simply our answer. Okay, so A is equal to 19 and B is equal to 13. So that is lovely, right? We've got 19 plus 13 root 2, where A is 19, B is 13. Perfect. Good. Number 8 says this, a bit more of a wordy question, I think. Without using decimal approximations, explain why 3 root 2 is larger than 2 root 2. Okay, so without just putting it in our calculator, I've got to explain to you, we've got to explain why is 3 root 2 greater than 2 root 3. So the way that I'm thinking about doing this is, well, I know that 3 can be written as a third as root 9. So I can rewrite the first one as root 9 times by root 2. Again, this just means times. You can write that dot. You'll see it in year 13, but it just means times. And similarly, if I go over here and write greater than, well, 2 is the same thing as root 4, because root 4 is 2. So I can just write it as root 4 being times by root 3. And then using our laws of surds, right, we know that root A times by root B is equal to root A times by B. Okay, so here we've got root 18 is greater than 4 times by 3 is 12, greater than 12. So you can see clearly, right, they're both in the same format, that root 18 is clearly bigger than 12. So you can go and finish off and just say that 18 is bigger than 12 by comparing the number inside your surds. Okay, so there we go. What's happened there? Question. Okay, that's fine. Question 8 and 9, just a silly mistake in my thing. Okay, so question 9 is solve this. Solve means you want to find that missing variable x, and straight away I'm thinking, right, you've got root 27, root 3, and root 48. The more that you do these, the more you recognise, right, you can simplify root 27, so it's got a 3 in the third, and also you can see, right, if you've got a root 3, because 3 can't be simplified any further, you sort of know that 27 and 48 are going to be simplified, so in the third, there's going to be a 3. So if we go and sort of consider, well, root 27, how can you write this to begin with? Root 27 is the same thing as root 9 times by 3. Well, root 9 is equal to 3, so 3 root 3. Similarly, root 48, we've seen it before on a previous video, is equal to 16 times by 3. So 16 times by 3, which is equal to 4 root 3. But you can now see, right, root 27 is in terms of root 3, that's in terms of root 3, root 48 is in terms of root 3, which is perfect. So now overall I'm going to be getting, well, if I rewrite the statement, I've got x root 27, we now know is the same thing as 3 times by root 3. And that's equal to 5 times by x root 3 plus 2 lots, root 48 we now know is equal to 4 root 3, like this. I could write a bracket there if I so wish. Okay, I'm actually going to rewrite this first bit a bit differently as 3x root 3. Just kind of rewriting it. I don't know why I'm doing that, but you know what, actually I'm going to leave it. We should really write it as 3 root 3x being equal to 5 root 3x. I'm just writing like the number part first. It just, in my head, it makes a bit more sense. Okay, then we've got 2 times by 4 is equal to 8, so plus 8 root 3. Now, actually, these parts here, 3 root 3x and 5 root 3x, these are like terms. If I get them onto one side, I can combine them, which is good. This part isn't a like term because there's no x, so I'm going to leave this on the right hand side. So I'm actually going to go and take away from both sides, take away 5 root 3x, and basically just get this over to this side. So then I'm going to be getting 3 root 3x, take away 5 root 3x being equal to 8 root 3. I can see actually I've got root 3 on every part of my equation, so I can just divide through by root 3, bam, 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 which is good. Okay, I've then got 3x take away 5x, which is equal to negative 2x, so I've got minus 2x is equal to 8, which then of course means x is going to be equal to negative 4, which is my answer. Okay, so there we go. So actually becomes quite an easy question if you just change the surds in terms of all being into root 3. Okay, last but not least, we've got rationalise the denominator of this one again. So let's write the question out. We've got 1 over 2 root n, take away 3. I think it's just a case of, well, rationalising we know means get the third onto the top. We're just going to be timesing through here by the expression on the bottom, but change the sign. So 2 root n to root n plus 3. The same on the bottom, 2 root n plus 3, because then of course you get the difference of 2 squares on the bottom, which means the thirds cancel out. So that's going times up the numerators to begin with. We're doing 1 times by 2 root n plus 3. Well, 1 times by 2 root n is going to be just 2 root n. 1 times by plus 3 is going to be plus 3. And we are, of course, dividing that by, and we now know that this bottom part, again, difference of 2 squares. That can be written in the form a plus b, a minus b, which goes into the form a squared plus take away b squared, sorry, where a is equal to 2 root n and b is equal to 3. So a squared is going to be 2 root n squared, or 2 squared is 4, and root n squared is just going to be n, so 4n, take away b squared, b is equal to 3, 3 squared is 9, so 4n, take away 9, which is actually the difference of 2 squares. Again. Anyway, we'll come on to that. So the bottom part gives us 4n take away 9. Let's go right to the bottom. So 4n take away 9. And I mean, I've rationalised the denominator. Sorry, what am I thinking? Right, this is not the difference of 2 squares form at all. Because I can't, sorry, if it was n squared, then it would be, but it's just 4n. So I believe quite an easy one to finish up with. But I think that's just it. Okay, that is your answer. So 2 root n plus 3 over 4n take away 9. I always get a bit kind of, that is your answer, but I always kind of think when you get an easy question towards the end, have I done something wrong? But no, that just is the answer. Okay, so good. Hopefully that was useful. And we'll get on to the 2 blue intermediate questions up next. Thank you.